Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. So far we've seen dummy variables, shifting intercepts, and interaction terms that allow effects to change. Now we combine both ideas and we try to answer the question, what happens when a continuous variable interacts with a dummy? The first step is let's write the model and what it would look like. So let's assume we have a model that is y being equal to beta 0 plus beta 1 x plus beta 2 d plus beta 3 x times d and an error term. We're going to assume as usual that y is our income, and we've got here x being education. Let's say number of years, so that's a continuous variable. And then d is a dummy variable, which is equal to 1 if, let's say, we are employed. Okay, so let's compare this to the dummy-only model that we have seen previously. We've done only y equals to beta 0 plus beta 1x plus beta 2d plus an error term. So as you can see, the only difference between the two models is definitely the interaction term in here. So what is it exactly adding then, this interaction to the model that we already know? Let's do the usual case by case so that you can really see what is happening in here. So let's start with case 1. As usual, for case 1, let's assume that d is equal to 0, meaning we're looking at the unemployed people or subsample of our sample. The model would look y hat being equal to beta 0 hat plus beta 1 hat x. Okay, so from this case scenario in here, we can very clearly see that the beta 0 hat is our intercept, and beta 1 hat here is the slope. And keep in mind, intercept and slope for the unemployed subsample. Let's look at case 2. Case 2, d is equal to 1, in which case we are looking at employed people. In here, now the y hat will be equal to beta 0 hat plus beta 1 hat x plus now beta 2 hat, okay, plus beta 3 hat times x. We can see that we've got x and x here, and then we've got betas without x attached to them, so beta 0 and beta 2 hat. So let's rearrange this expression and rewrite it as beta 0 hat plus beta 2 hat, so these together. And let's factorize the x, which means that now I have beta 1 hat plus beta 3 hat here times x. Okay, so from here, very clearly, we see that the intercept is beta 0 plus beta 2 hat, and the new slope here now is beta 1 hat plus beta 3 hat. So look very carefully what's happened. We have a shift in the intercept. And that shift in the intercept is the beta 2 hat. At the same time, we also have a shift in the slope. And that shift in the slope is the beta 3 hat, because that's what is changing from this estimated model that we had in case 1 to this model that we now have estimated for case 2. So not only are the intercepts different, but also the slopes are different between the two groups, which if we compare to the dummy-only model, without the interaction, So dummy times dummy, or just simply the dummy only actually model. What you had without, so here, yeah, without interaction, what you had was simply parallel lines, okay, which meant same slope, but different intercepts. Instead now, with the interaction, what you have is no parallel lines, because as you can see, the slope has changed. There has been a shift in the slope. No parallel lines, and also both intercept and slope are different. So intercept and slope are different. Okay, so this is an upgrade overall. And the beta 3 tells us how the effect of x changes when d is equal to 1. Okay, so it is the change in the return to education when someone is employed. Now, keep in mind that if beta 3 here is actually equal to 0, then the interaction is adding nothing. The lines are still parallel, and you'll be back to basically the dummy-only model. And this is a very useful special case that you will have to keep in mind, especially if you have to draw the graphs for the fitted lines. Now, what about real-world interpretations? Does education increase income more for employed individuals than unemployed ones? The answer to this is going to be very straightforward and depending on beta 3. So it means that if we have a beta 3 that is actually bigger than 0, it means that education matters more for the employed. Then if beta 3 is actually smaller than 0, it means that education matters less for the employed. And then if beta 3, as we said earlier, is actually equal to 0, meaning that education matters equally for both groups, okay? So in a dummy times continuous interaction, the beta 3 is measuring how the slope of x differs across the groups. In the next video, we'll derive this formally and compute the marginal effect step by step. So stay tuned, and I'll see you in the next video.